Okay, we're back. We're doing the last day of notes for Unit 6. This is the 6.6 or the 6.7 applications piece. The only part that we're doing from this section is going to be solving for a variable. We did this in Algebra 1, a little bit in geometry as well, and that's just getting a letter by itself when it says to solve. This number 1 says to solve for y. That just means we're trying to isolate y. Okay, so they're going to give you a problem. They're going to tell you what letter to get by itself, and we're going to have to do some basic algebra skills in order to get that letter by itself. So for number 1, it's an easy one because we're only having to do one step here. In order to get this y value, which is already positive by itself, we just have to subtract 2x from both sides. And when you subtract from both sides, it'll cancel out the 2x and the negative 2x on the left side. I'll be left with that positive y. On the right side, those two are not like terms, so you have to write them separately, the 6 and the negative 2x, so those two terms. The negative 2x would go first because you're supposed to write the variables first and then your constant last. And that would be your answer when they ask you just to get y by itself. If they ask you to get x by itself, you'd have to subtract the y and divide by 2, but they didn't ask that for that problem. The next one, a little bit more difficult, almost the same, but a little bit more. We'd still subtract the 2x over, and they would cancel, the 2x would cancel. I'm left with negative y equals negative 2x plus 4. But in this case, we still have a negative attached to the y. That means that there's a 1 out front. So that means I'm supposed to divide. If it's attached by multiplication, the inverse would be division. So if I divided by that negative 1, the negatives would cancel in front of the y and underneath it. And then I'd be left with 2x and then a minus 4 for that problem, getting y by itself. So those are the first two. Those are easy. The next two are a little bit tougher, getting y by itself. Example 3, we would have to subtract the 2x again. Now we're left with negative 3y equals negative 2x plus 6. Divide again by what's attached. And now we have a fraction that I see is going to be set up for in front of the x. So two negatives equal a positive. So it'd be positive 2/3. We'd still have that x there. And then 6 divided by negative 3 is a whole number. That's negative 2. So there's your answer for 3. Then for 4, to find the answer, you'd have to subtract x and subtract 1. So if we subtract x and 1, they would cancel on the left side. We're left with negative y. On the right side, we have negative x and a positive 2, because 3 minus 1 would give me positive 2. Then you divide by negative 1. And in the end, you'd be left with positive x minus 2, and that would be getting y by itself. So those are the basic ones that we saw from algebra, and a little bit from geometry. Now we're going to do a little bit tougher problems. For number 5, it asks you to get y by itself. The only way that we can get y by itself is putting these two fractions down to one level. And you learned last year about the means extremes product theorem. And the year before, you learned about cross multiplication. Both of those things are one and the same thing. And if you just cross multiply or do the means extremes product theorem, you'll have a 3, and it'll be multiplied by y minus 5. You'll have a negative 4, and it'll be multiplied by x plus 3. So what that does is it goes from two fractions now to just having one level as opposed to two levels there. And you can put that negative sign on the bottom or top. I just chose the top, but it's up to you. You can do either one. You get the same answer. If you distribute now, you'll get 3y minus 15 equals negative 4x minus 12. And then from here, I'd move anything that's not a y to the other side like we did up above. So we add 15 to both sides. We get 3y, those cancel, equals negative 4x plus 3. Divide by 3, and we're left with a similar process to what we did up above. We have negative 4/3 plus 1 in the end. So that's a little bit tougher. We had to do a little bit more math. Oh, negative 4/3 x, that is. A little bit more math, but it came out to to be a pretty clean answer. And that x would actually be on top. I mistakenly wrote it kind of on the bottom. It'd be on top or on the side. And the side always means on top. All right, so for this next one, it's the first one that we don't have to solve for y. It's asking us to get h by itself. So h is over here on the far right of this one. So we're trying to get this by itself. Ooh, gotta go thinner on that. Let's see what this looks like. Oh yeah, so thinner. So to get h by itself, all those things in front of h are attached by multiplication. So all we're gonna have to do is divide both sides by 4/3 pi r squared. 4/3 pi r squared. And now that would cancel everything out that's on the right side. On the left side, I have a 1 that's in front of the v. So that's 1/1. And if you take a fraction divided by a fraction, that means the same thing as a fraction multiplied by the reciprocal. So this would be 1 divided by 1 divided by 4/3. And you guys learned that if you multiply by the reciprocal, you get what the new fraction would be as a single fraction. So now we have 3/4. And then on the top we have a v, and the bottom you have a pi r squared. So that would be your answer for h. And we used a little bit of advanced algebra there to get us to 3/4 instead of a 1 divided by a 4/3. Ooh, 6. Let's go down to 7. Solving for y now is a little bit more difficult because we have multiple variables. We have a y, an a, and a b. When you have all those variables, we're always trying to pull out a greatest common factor if possible. And then you're going to see that it makes your life a lot easier. So on the left side, we can pull out a y. And we're left with 3 minus a. And that means that that 3 minus a, you can divide because it's attached by multiplication. So we can divide, and that's really negative a plus 3 if you wrote it in order with your variable first and your constant last. So they would cancel each other out, and we're left with y equals a plus b. And then we would accept 3 minus a, or you can write it as a plus b and then that negative a plus 3. Both of those would be good answers. I think that on your multiple choice, it's going to be written like the right side, though. A plus b and negative a plus 3. So that's a little bit more advanced. Solving for y for number 8, we'd have to multiply by the, the LCD. If you look at the bottoms, that's where you get the LCD from. And it looks like there's an a, w, and a y. So to get rid of fractions when there's not just 2 fractions, but there's multiple, that's when we multiply by the LCD, and we learned that already this year. So if we multiply by a, w, and y, that's every single numerator is going to be multiplied by a, w, and y. And what should happen is there should be no fractions left over after you multiply by a, w, y. So these y's would cancel, and I'd be left with a, w. The w's would cancel, and I'm left with a squared y. The a's would cancel, and I'm left with w squared y. And then this problem is asking you, now that we got rid of all the fractions, it's asking you to get y by itself. So again, what we did for number 7, we'll have to do here, where we pull out a greatest common factor of a y, and we're left with a squared plus w squared on the right side. And then because that's multiplied by y, I'm going to divide by a squared plus w squared in order to get the y by itself. So those will cancel each other out. Now y is isolated. In the end, we have aw divided by a squared, a squared plus w squared. So that's a tougher one too, getting rid of the fraction. 9, we did one like this up above. I'm going to go quick on this. This would be a cross multiply one. And then it becomes a normal one where you move all of your numbers to one side, all of your variables that are you're trying to get by itself to the other, and then you divide by 2. So in the end, it's 7/2 x plus 41 over 2 is fine. I think that comes out to give you nice decimals, even though they'll leave them as fractions. More than likely, that would be your decimal answer. You can only write it as decimals if they come out to be nice decimals like that, where they don't go on forever. Solving for t, we would have to cross multiply, so we get tab t times a times b is equal to p times v times s. And then to get t by itself, we divide by ab. Cancel, cancel. That would be our answer for number 10. I think we got 2, 3, 4. Okay. I see the same problem twice. So, no, I don't. One says solve for y, one says solve for m. Okay. So if we're to solve for y for this first one, we got to get rid of the bottoms. So that's the LCD again. I'm going to multiply by x, m, and y because that's everything that's in the bottom. So you're going to do that to every single fraction. X, m, y, x, m, y, x, m, x, y, m, I guess for that one. Doesn't matter the order. So the x's will cancel. I'm left with 7my for the left side. In the middle, the m's will cancel, and I'm left with x squared y. On the right side, the y's would cancel, and I'm left with zxm. Probably not the greatest alphabetical there. So they're asking you to get y by itself. So I'm going to move all the y's to one side. Oopsie, didn't mean to do that. My. So I moved the, I think that's in alphabetical order now on the right side. I moved that x squared y to the left by doing subtraction. And now once you have the y's on the same side, you can pull out a GCF of a y. That's what we did up above. So now we're left with 7m minus x squared. And there's no more y's on the right side. And then because this y is multiplied by that parentheses, you can divide by the parentheses on both sides. And it gets rid of everything attached to the y. And now you're left with negative mxe divided by 7m minus x squared, or negative x squared plus 7m. Either one would work. So that's your 11. I'm going to do one more. I'll do 12. And then 13, 14 is very similar to 11. So that way these notes don't go crazy. I'll just do those quick so you can press pause if you want to. All right, so this is asking you to solve for b. So if you were to get b by itself, you have to first distribute this half in. Oh, there's an h2 there. All right. Half c multiplied by h. So if you multiply all this out, you get 1/2 bh plus 1/2 ch. And then to get b by itself, I'd subtract this half ch over. Half ch. So now we have a minus a half ch equals a half bh. I divide by a half, which means the same thing as multiply by 2. So now we'd have bh equals, if I multiplied the left side by 2, that'd be 2a minus ch. Oh, that's the wrong. H, it's lowercase. Shoot. Where's mine? There it is. Back to this. It's lowercase. And then to get, what did it want? B by itself. I would just divide both sides by h. So I'm going to divide everything by h. So in the end, I have b equals, and that would give me 2a over h minus, and then those h's cancel. it'd just be C. So that'd be your answer for that one. And then you can press pause and see if you get these other ones right. I'm going to go quick. So your LCD is X, M, 2, and a Y. So that's going to multiply by all the tops. So now that would be X's would cancel. I'm off of 14 MY equals. The M's would cancel. And that's 2X squared Y. And then the 2 and the Y cancels. So I'm left with MXZ. And then you're trying to get M by itself. So I'd move all the M's to one side in this case. So you have to add M to both sides. And then you can pull out a greatest common factor on the left side. So if you pull out an M, you get 14Y plus XZ equals 2X squared Y. And then since the M is by itself by multiplication, you can divide by this binomial from both sides. And then that will cancel, and then you'll have M by itself. So it would be this.